Hello everyone, welcome to the next session of SAP Basis Training. In this session we will be discussing about architecture of SAP NetWeaver application server. As we seen, the architecture of SAP is three-tier architecture. Okay, we have three different layers of SAP in the entire landscape. That is, first one is client tier and application tier and database tier. The client tier we call this as a presentation layer, or then application tier is like application layer and database layer. The client tier, that where we have the SAP GUI, web GUI, and it can be also RFC. RFC means remote function call. It can be another SAP system which is calling this SAP system, or it can be a non-SAP system. Okay, non-SAP system also you can call SAP. For example, Microsoft servers. Some of the Microsoft server have remote function calls, where using that remote function call you can call an SAP system. You may think, what is remote function call? Why do I need to call SAP system? For example, you have a Microsoft solution for BI or some another web servers. So whereas you want to call SAP to pull out some data from SAP, that time you will call a remote function call which will have a user ID and password. You can log into our SAP server. Login means you can call logically using the TCP IP address of this particular server. You can call this one and pull the data from here. This is called remote function call. Okay, it can be a remote function call, it can be an HTML client, or it can also be a web client. Like this we have NWBC and lot of clients. Okay, then we have application server. The application tier, we have application server 1, 2, 3, like this. You can have multiple of application servers. Okay, and we have database layer. The database layer is only one. You cannot have multiple database layers. Okay, so you can have only one database. All these application servers are pointing to this particular database. It can be SAPDB. SAPDB is SAP's own database, and you have SQL Server, or it can be an Oracle. It can be any supported database. So we have one database. It's called by multiple application server. So let's, for example, SAP GUI. For example, if you are logging from SAP GUI, 10 user is logging from SAP GUI, it can be distributed to different application server in order to have the load balancing. That's what we have seen in our previous session, that you can create a group. You can create one group, or you can also create multiple groups. You will see how to create these groups later. And so using these groups you can also log into one application server with, then it will allow you to one work process. That work process will do your process and it will interact with the database. So every users and every application going to use the same database. This is a interesting part of SAP. Okay, you have multiple application server, one database, you can have different clients. Okay, so the repository, the central repository of the system, the database is only one. Okay, so this is three-tier client server architecture. Client server architecture means you have a client, or you have multiple clients and server. Whenever the client requests your process from the server, it will request the process from the server and it will process it and gives back to the client. This is a client server architecture. You can differentiate client server architecture into software oriented client server architecture and hardware oriented client server architecture. Meaning to say, for example, in the server you can have each application server, you can have one specific box. Yeah, box I mean a hardware computer or a system, yeah, server. You can have individual boxes like this, hosts. Or you can also have software oriented architecture, meaning to say in one system but you have multiple application server, like a virtual systems. Okay, not as same as VMware's. You can have one operating system, but you will have different application server, like what we see in different instances, right? So instance 00, you can have additional instance 02, like this you can have additional instances, or you can have additional application servers in the same box. Okay, this is software oriented architecture. You can differentiate it like that. here we say 3-tier architecture does not mean it has to be exactly 3-tier architecture. In SAP R3 this is a recommended architecture. We used to have SAP R2 before, that means 2-tier architecture, whereas application server and database is in the same system. Yeah, it's used to be one, and you have one client which will call this one. Yeah, here we have separating it into two, which is a 3-tier architecture. Or you can also have multi-tier architecture. You can have in the middle something, an internet system or internet provider which will be sitting there and distributing your request. It can then again we can call this as a multi-layer architecture. Okay, or we can say a single layer architecture, which can be a one laptop for example, and which have your SAP server, host, SAP application server, database, and SAP GUI, everything together. We can say it's a single tier architecture, but logically it's separated by software, but still it's in a single host. Okay, here we can see the 3-tier architecture is explained in more detail. We have the presentation layer. For example, let's take SAP GUI for our presentation. From here onwards, SAP GUI is our presentation layer, and where user will use this PC and log into the system. Then it comes to an application layer. The application layer, the SAP instance. Okay, SAP instance can be installed in Windows or Unix platforms, and we have, you can see the request comes to the SAP instance dispatcher. It's a all request whenever you log into the system, it comes to the dispatcher. The use of the dispatcher is the job of the dispatcher is it dispatches the request, yeah, to the specific work process. We seen before WP, it's a work process. Yeah, we have different kind of work process: dialog work process, background work process. We will come to that in detail, what is each does this. And then the dispatcher will put this request into the request queue, and it will go allocate the each work process. D means dialog, B means work process, update work process, NQ work process. We will see that each one in detail, but this is work process, means a process, collection of resource which can process your request. Okay, and here you have, in this case also you may think, okay, let's say I have 100 user logging into one same time, but you have only 10 work process. How are we going to handle this? Okay, that is the use of request queue. So it comes in first out basis. Who comes in first, it will allocate. Once that is finished, and it will allocate the next one. It does not mean that one user logged in to the system, one work process is allocated, then it cannot be used by anybody else. Only in that case only 10 user can use it, right? No, that is not the case. Let's assume that you have 10 work process. These are all, let's assume these are all work process. 10 work process, you have 100 user logging in at the same time. Okay, 100 user, not say logging in, let's say trying to do some activities, yeah, but you have only 10 work process. What happens is the request queue will allocate one work process for this user, then it will process the whole thing. Once finished, then this is free, then it will give it to the next one, the same work process. The same work process, you can see multiple user using it in a different time frame. Okay, so it does not means once you allocate one process, then the work process is blocked for this user. Not that. That is the very interesting part of SAP. It will keep allocating to different user based on the workload. Okay, so this is the application server's job, and here only you will be executing these programs and reading these tables. All these things will be done here, the application layer. Then we have database layer. Database can be any database. You can see Oracle, Informix, DB2, SQL Server, and MaxDB also we can use. So whenever this particular work process needs some data from the database which is saved in the data, it will call the database and it will extract the information from the specific database. Okay, so it's very easy, it's very important to understand this concept. The database instance, we call this database instance. It can be also a separate box. Okay, the user in SAP GUI, same like what we see in the SAP basis when we logged in, that user directly does not interact with the database. it does not logs into the database, it logs into the application server. So the request, whatever we processed, whatever we did in our SAP GUI is processed here. So when the SAP GUI wants to call some database or some data from the database, it will call the database internally. Okay, not the user which you logged in is going to call. Same like your Oracle, you can create a user in the Oracle and you can log into Oracle, right? That's not the way it works here. The interaction between application server and database is done by a separate user and which have a separate logic. We will come to that very detail about that. Okay, there is a couple of few users only used by from database to SAP. Okay, that's we have a quite very complex security logic there, so that it cannot be like the security cannot be breached in any way. Yeah, so it's a very interesting topic how the SAP interact with the database. It's another topic, but the point which I'm trying to make it here is that the user which you are creating in SAP is not created in the database. It's a table entry again sitting in the database. However, it's not the user which will interact with your Oracle, for example. Okay, that's a separate SAP database. That's a separate so SAP, that is a separate SAP user. So SAP user is different and database user is different. So this is our database layer. It will interact like this. This is a 3-tier SAP system architecture. Now let's have SAP instances. We are talking about SAP instances, right? Here again we are talking the same layers: presentation layer and application layer and database layer. When you install an SAP system, you already have an option to separate the process at an application level for those at database level. That means that the database for an SAP system can be installed and operated in a separate physical computer, okay, separated from instances and SAP system. The entire database can be installed in a separate instances. This is exactly one database for each SAP system. Okay, there is one database for each SAP system. The database usually have the same SID, that is DB ID, database ID, as SAP system. Okay, when we logged into our SAP system, you have seen ECC, that was our SID. Okay, and the DB ID will be also ECC. Okay, you have only one host. It can be a physical host or a virtual host which will carry DB ID, ECC. Okay, ECC as an example. Then let's see application layer. The application layer, you can see host A, host B and host C. Okay, here everywhere you can see a dialog instance and something called central instance. So in host A we have central instance. The central instance of an SAP system is identified mainly for the offers or the services that no other instances will hold in the application layer. Meaning to say, the central instance is one of the controlling body of the entire application layer, we can say, which will have something called message server and the enqueue work process. Enqueue work process is basically will handle your locking mechanism of the database. Okay, so message server, we can call this as a message server, which is the central controlling body of the entire application layer. Okay, this is for the ABAP stack. For Java stack we have different one. We have something called SDM, which is software development manager, which is like a central instance. And we have another dialog instances. The other dialog instance, it can be separated by boxes, as I said, different host, or it can also be installed in the same host with the different names, yeah, with the different resources. So the dialog instance is additional resources which will support the central instances. So central instance is the controlling body of the whole entire system here. okay, which has the message server. Okay, let's go to the next slide, then we will get into more detail about this. Here you can see the SAP instances. Okay, each SAP instances will have its own dispatcher. Okay, this you can see it more detail in the application server what we are doing. Let's say for example this is our central instance and this is the message server. Message server interact with the dispatcher. You can see here the central instance, what we have additionally is the message server. Okay, the message server interact with each dispatcher. You can see here, so dispatcher dispatches the work. It's basically its job is it takes the command from message server, there is a request from some SAP GUI, then some work process needs to be assigned. Okay, the work process are basically you can see here D means dialog work process, this is update work process, NQ work process, or LOC management, or background work process, or spool work process. We have another slide which explains this more in detail. Okay, so the message server takes this information, give it to the dispatcher. Dispatcher finds which work process, what all the work process which is free here. Okay, then it will allocate to this work process, whichever the relevant work process, yeah, which will allocate to the work process. And each instance in the application is connected to the message server. So you have one central instance, you can have multiple instances. Okay, that is the idea behind the instances, additional instances. You can have multiple additional instances, and the work process within the instance can also be vary. It does not mean that if all the work process should have the same instance. For example, this instance it's a small box, it have less memory and less processing power, then you will have less work process in this instance A. Okay, and after some time you realize you wanted to increase the capacity of the SAP system, then because there are so many users came in, you cannot handle it, then you can buy an additional box, add an additional instance which will have more work processes. That's a way you can increase the SAP resources quite easily, and you can easily adopt to the existing landscape. As I said, it does not mean that you need to have this work process, the same work process everywhere. It can vary, but the central instance you have some difference, but you need to have all the work process should be in central instance. For example, it should have, because there are some instances controlled by central instance, and another instance it can be in the dialog instances. Let's see more detail what is this each work process means, then you will know, you can understand this far better. Okay, here is an application server ABAP work process. You can see here the ABAP message server. It's a message server. The message server interact with each dispatcher. Yeah, that's what we have seen. So you have one message server which is sitting in central instance, and the dispatcher, each application instance will have a dispatcher, and the central instance also like an application server, so it's have its own dispatcher. You can see it here, it have its own dispatcher. Also each application server have its own dispatcher. So the message server interact with the dispatcher, the dispatcher interact in turn with each work process. Then we have gateway. Gateway is nothing but it's a interface between the external environment and the internal environment, internal SAP system. Okay, so we have an SAP instance, SAP gateway instance. So if let's say you want to control all the incoming request to an SAP system, you can use a gateway instance, so that you can reroute all the requests coming from an external environment to the SAP system using the gateway process, gateway instance. Okay, then we have Internet Communication Manager, that is the ICM, that which we have seen it before, which is used for Java instance. Okay, so if we have a web request, it go to ICM, ICM go to Java dispatcher, then it will allocate the process. we were seeing about the dialog, the work processes. Yeah, we seen D, B, E, V and S. First of all, we need to understand what is a work process. Work process is means a collection of resource, or collection of resource means, don't imagine that one process is allocated, one processor is allocated to one work process, or some amount of memory is allocated to one process. It's a logical resource allocation. Yeah, so there is one process which will execute some of the requests coming from the user. Okay, it's a process, it's a logical process which will execute mainly the request coming from the user or from a different request. Okay, so we have different kind of work process. First one is dialog work process. The dialog work process fulfills all the requests for execution of a dialog step. Okay, it's a dialog step. Dialog means when you log into SAP system, you are doing a dialog process there. Okay, you log into SAP system using SAP GUI, it's a dialog process. So the dialog steps triggered by an active user are executed by dialog work process. Every dispatcher requires at least 2 dialog work process. It's very important. Yeah, please note it down. Every dispatcher in every application servers which we have seen, the central instance also here considered as one application server, okay, which requires minimum 2 dialog work process. The dialog process, one of the main work process which will execute the steps, or which will execute the programs which is triggered by an active user. Active user means, for example, if I log into SAP system and trying to do something, I'm an active user, I'm a dialog user logged in by SAP GUI or any client. Okay, that's a dialog user which will execute. So the dialog work process will execute the steps executed or the programs executed by this dialog user. Okay, next one is, let's say, background, B. Okay, represented as B. It's a background work process. The background work process execute programs that run without interaction with the users. Meaning to say, let's say I have a program which I wanted to run it every day, okay, which will give me some result. Result in the sense, now you may think, okay, how can it gives you a result if you are not in the screen? Okay, it can be send it by email, or it can trigger some another activity, it can be anything. So the background work process execute the programs that can be run without interaction of an user. And the minimum requirement for background work process is at least 2 background work process for each SAP system. Here minimum requirement is 2 background work process for the SAP system. It's not for the dispatcher. And however, you can configure more than 2 work process for dispatcher. Okay, this is again very interesting thing. When you are doing a load balancing analysis or load balancing in your bigger system, that some of the client, what they prefer is they wanted to have some instance that's only dedicated for background process. You may think, why do we need to have a dedicated server? Do we have so many works? Yes, if you see in a larger systems, there will be a lot of jobs which will be scheduled as background jobs. This is very important. Yeah, these background jobs also can help quite a lot in the business, and it can also destroy your system some cases if you don't manage it properly. Okay, so you can schedule background jobs to do some task. Okay, so you can have more than 2 work process. Minimum requirement is 2 work process, 2 background work process for an SAP system, because when you log into SAP system, it will trigger some background jobs. There is a lot of background jobs is triggered by default by SAP. Okay, you need to have at least minimum 2. Now let's come to lock management, which is called NQ, which is represented as E. The NQ work process is an administrative lock table in the shared memory. Okay, so the lock table contains the logical database logs of an SAP runtime environment in an SAP system. Meaning to say, if you know a little bit of programming, you know this. If you are calling a record, if you are open a record, the record should be locked, right? It should not be updated by somebody else. So the lock management, what it does, it's a work process. It will manage the all locking mechanism of the tables internally. Yeah, so in the SAP, when you do a programming in SAP, for example in ABAP, generally people don't worry about the locking mechanism, how the record is going to be locked and stuff like this. It will be managed internally by SAP itself. The process who is going to do this one is the lock management process, which is an NQ work process. Here lock management process means NQ. E is an NQ work process. Dialog, background, NQ work process. Main thing to remember, this also may be some of the interview questions. Also, if you are going for certification, they will ask these questions. There will be only one NQ work process in an SAP system. Okay, there is only one NQ work process in SAP system. Why can't we have more than one NQ work process? Because locking mechanism should be managed by one person. Okay, one work process. If you have an additional work process, which table has been locked by one cannot be identified by another, then it will be a chaos there. So the logically you need to have one NQ work process per one system. You cannot have more than one NQ work process. So the person who is holding this NQ work process is the central instance. Okay, you cannot have NQ work process in an application instance. So it will be in the central instance. Then we have V. It's an update work process. The update work process execute update request. Meaning to say, after you will do some operations, you have to update these changes into your database, right? Who is going to do that? This is an update work process. This update work process can be more than one work process in an SAP system, but minimum requirement is you need to at least to have one update work process per SAP system. Okay, so you can have more than one update work process in the SAP system. This is again very important. NQ you can have only one. Update can be done by many. Okay, because why you need to have more than one? In some cases, if you are doing quite a lot of updates, quite a lot of updates in the table in your SAP system, but you have only one update work process, maybe it cannot handle it, because you have lot of work process, dialog work process and background work process doing some update, then it cannot be handled by one update work process. In that case, you can increase the update work processes. Okay, you can have more than one update work process per dispatcher. Okay, then we come to spool. Spool work process pass sequential data flow to the printer. That is the definition of spool work process. Sequential data flows means basically spools handles printing. Okay, in a layman's language, if you wanted to say, spool means printing. Okay, spool process work process, what it does, it takes the request from the dispatch. For example, dialog or background. From a dialog, I am trying to, let's say for example, from the dialog work process, I am trying to print something. Okay, then it will go to the spool work process, then it will create a spool request. Okay, it will kind of a collection of information based on the program which I executed. I got an output. This will be created as a spool request, which will have its own number, which will be handled by the spool work process. So the spool work process, what it does, when the printer is free, it will send the spool request to the printer for printing. That is its job. Okay, at least one spool work process is required for each SAP system to handle the printing. You can argue saying that okay, if I don't have a printer at all, if I don't do any printing, do I still need the spool work process? Yes, because you will do some activity which will have some output, which is a spool output, which also can be saved for different purposes, which can be sent as an email, or which can be saved in the database for which can be saved in your SAP for further references as a log. Okay, so spool work process handles all the spool requests for printing. You can have more than one spool work process for per dispatcher. Okay, meaning to say if you are doing a lot of printing activity, then you can have additional spool work process. As I said, if you want to tune your system properly based on the business requirement, if the printing is quite a lot and you have a lot of printers to do, if you have a lot of printers and a lot of printing is going on, then you can keep one application server which have quite a lot of spool work process and who will do only the printing operations. That also one way of doing it. Otherwise you can distribute it. Again, that's again depends on how you want to design it. Okay, if you put every spool work process in one application server and keep it in one side, if the particular application server is down, the entire printing in your landscape is gone. Okay, that is not also not a good idea. So we will come to that, how to create the spools and how to create the spool servers and stuff like this will in the later stage. But to understand, so you can also create that, or you can also distribute it. So in general, the dispatchers of an ABAP instance manage different type of work process. It can be a dialog, update, background, enqueue, spool work process. These work process work on different tasks when executing a business process in the SAP system. The administrator of an SAP system, as a basis consultant, you can change the work process configuration using parameters configuration. There is something called parameters in SAP. Using that parameters, you can change these work processes. Like you can increase and decrease the work processes. We will come again to that one later. Now we are still in an introduction part of basis. We are still learning the architecture of basis. Okay. So in addition to the work process, we have additional services which is in the instance, which is first of all the message server. This MS message server is one. There is only one message server for your SAP system. So message server interact with your dispatcher, dispatcher interacts with the work process. Okay, that is the work of message server, so that it can have the load balancing between each application server. For example, this one application server, you have 4 application server, you have only one message server in the SAP system which distributes its work to the dispatcher, and the dispatcher will distribute to the work process. Next one is gateway. Gateway enables you to communicate between SAP system and the external environment, or between SAP system itself, or between different SAP system itself. Okay, this can be one gateway for dispatcher also. And next one is ICM, Internet Communication Manager. This enables communication between SAP system and HTTP, that means web protocol, and ICM requests from a client are forwarded to SAP. For example, it can be also ABAP, or it can be also Java. So what happens is, if you are getting an ICM request from an external environment, ICM recognize this as an Java request or it's an ABAP request. So it will recognize that. If it is an ABAP request, it will send to the ABAP dispatcher, then it will locate the work process. If it's a Java request, it will go to the Java dispatcher and it will assign the Java work process. Okay, you can have more than one ICM process per application. Oh no. And the ICM request also same like your message server. You can have only one ICM process per application server. Oh no. Again, the ICM and again. We can have maximum of one ICM process for application server. Now let us have a look at to the Java application server processes. Okay, these are all the process which is available in Java application server. First one, let's have a look into what is Java dispatcher. Same like our ABAP dispatcher, Java dispatcher distribute the incoming request to the server process. Then let's see what is server process. Server process execute the Java application. Okay, every server process have a large number of process, that is called multi-threaded processes, can be executed by one Java server process. So it's a contradiction from the ABAP work process. If you see ABAP work process, it is specific to one process in ABAP. In Java server process, every server process is multi-threaded and it can execute large number of requests in parallel. Okay, that is a difference between Java work process and ABAP work process. For every dispatcher, there is at least one Java server process is required. Okay, you have one dispatcher, then you can every dispatcher should have one Java server process. You can have up to 16 server process for one dispatcher. Okay, now let's come to message service. Okay, the Java message service manage a list of Java dispatcher and server processes. Okay, in turn the server processes. It is responsible for communicating within the Java runtime environment and the server process. Meaning to say, the message service is linked to your dispatcher. Again, dispatcher is linked to your server process. So the message service in turn through dispatcher it communicates to the server processes. Same like ABAP. Okay. Then we have Java NQ services. We already know now what is NQ services, which is used for logical locking of the records. Same like in ABAP stack, in Java NQ services manage the logical lock which is executed by Java application server, or let's say Java program. Okay. Then we have one more, something called Java Development Manager, that is SDM. This SDM is a standard tool which is used for installing Java software component in the server itself. Okay, this is a Java Development Manager. It's basically where used to install Java software components in the SAP Java stack, that means SAP server. Okay, software development manager. Okay, just to review, Java dispatcher controls server processes. You can have up to 16 server processor for one dispatcher. Then we have Java message service, which connects to dispatcher. As we know, dispatcher distribute the job. Then the message service is basically the interface between your runtime environment and the server process. And NQ services for locking mechanism, and SDM is for installation. Okay, the main difference between ABAP and Java, in the Java server process, it's a multi-threaded process, so it can handle large number of requests in one specific process. The other way around, in ABAP you need to have one work process for each execution of the specific program on the specific time. Okay, that's the main difference. So far what we have seen is a ABAP process and Java process. Okay, so ABAP process works in the ABAP stack. It's a separate system. It can be a separate system. And Java process works in a Java stack. It also can be a separate SAP system. Or this, if you have only ABAP in one SAP, then we call this an ABAP stack. If you have only Java in one SAP, then we will have a Java stack. You can also have both together, ABAP plus Java in one SAP system. Okay, so let's assume that if these two different things are separate, then this will be connected something called JCO connector. Okay, Java connectors. So the ABAP application server ABAP system is a complete infrastructure in which ABAP based applications can be developed and used, and the application server Java system is a complete infrastructure for developing and using J2EE, that means Java based applications. In the system of ABAP plus Java system is a complete infrastructure, whereas ABAP as well as Java based application can be developed and used. The ABAP plus Java systems are mainly used like NetWeaver, PI for process integration, or solution managers, stuff like this. Now let us see the SAP application server ABAP architecture. Okay, so far what we are seeing is we are seeing only the architecture of the SAP system. This is very important to understand the SAP architecture as a basis consultant in order to analyze some of the complex scenarios, and if you want to build systems for a large scale systems, so you need to really understand what is the logic behind the architecture of SAP system. Okay, that's what in the initial sessions we will be learning more of the architecture. So it is very important that you understand this very clearly. Yeah. Okay, let's see ABAP architecture. In the ABAP architecture here, what you can see, we have central instance and we have dialog instance. As we seen so far, the dialog instance can be more than one, or only with central instance also you can run. Yeah, only central instance also is necessary. If it is a small system, you can run with that. If you want to have additional application server, then you can install the dialog instance. Okay. So if you see in the central instance, it is identified by the fact the message server and the enqueue servers works there. If you see in the central instance, you can see the dialog instance, the update instance, and the enqueue and background and spool. However, in the dialog instance, you can see dialog, we have update instance, and we have background instance, and we have spool, and you don't have enqueue here. Okay, you have only in the central instance. So the difference, if you see the main difference between the central instance and the dialog instance, is you do not have message server and you do not have enqueue. As we seen, the enqueue can be only one for the locking mechanism that will run in the central instance, and the message server, the use of the message server is the message server connects to message server, talks to all the dispatchers of different application server. So in the central instance, and this is like a small application server, so the message server talks to this dispatcher and message server also talk to this dispatcher. So based on the which dispatcher is free, the message server can take a decision and contact each dispatcher to do some specific task. Yeah, that is the idea behind that. So apart from the enqueue work process, all other instances, yeah, are called dialog instances. So apart from the central instance, all other instances are dialog instance, whereas you do not have enqueue work process, meaning to say it is providing a dialog services, whereas each process is named after the specific application what it is going to do. It's like dialog or background or spool or whatever it is. Yeah, or we can say the role of a particular process. Yeah, this named after the role of particular process. Okay. Maybe let's have a look into the system, how we can see these instances. Okay. So let's go back to our SAP system. Okay, this is our SAP system. If you log into our SAP system, you go to the transaction code SM51. Okay, then I press enter now. Okay, now it will come to the screen where it says the SAP servers. This transaction code displays the servers available in this specific landscape. In our landscape, we have only one server, ECC demo underscore ECC underscore 00. Okay, this is the server name, and this is the host name. The host name is the one, the actual name of the host. Yeah, the name of the computer, for example. Yeah, where it's installed. Okay, this is the host name is ECC demo, and this is the SAP server name. And you can see the message type. Message type means what kind of processes running in this particular server. You can see here dialog, batch, update, update to, spool, enqueue. If you are running enqueue here, that means this is a central instance. Okay, then ICMN, J2E, these are all the additional services it's running. Okay, the ICMN J2E is running here because this particular server which we are now seeing have ABAP plus Java stack. So in our case we have only one server. In case if you have more than one server, then what will happen is you will have one more line here with the server name, or multiple lines here with the server name and the host name and the message type, whereas you don't find the enqueue. That means that is dialog instances. Okay, you can also see the status of the servers, whether it's active or inactive. Okay, this is SM51. The transaction code is SM51. And remember, instead of this transaction code, if you forgot the transaction code, it's not a problem. You can go find it from this menu. Yeah, almost whatever we do in the basis is always in the tools. Okay, go to tools, administrator, and monitor, then go to system monitoring, and you can see SM51. Okay, it's quite easy to remember the path. So in general, in our basis scenarios, if you become an experienced basis consultant, normally we go by transaction code. That will come by practice. You need to practice it more so that you don't need to like keep remembering this transaction code. Even you practice it more, it will automatically comes in. So if you forgot, then you can still use this menu path, and if you are daily using it, you can just drag and put it in your favorite. If you just drag and put it here, then it comes here. If you drag and put it here, then you can see it comes here. Okay, so this is also one method of doing it. Otherwise you can use the menu path. Best way is to remember the transaction code. So once you practice it more, then you will automatically remembering the transaction code, because these are all the transaction code, we will be using it very regularly. Yeah, so this is SM50, and you can also use the transaction SM. So this is SM51, and you can also see a transaction called SM50 process overview. So what this process overview will do, let's say double click in this one, and this will give you the list of process running in this specific server. Okay, as we seen here, you can see the server name. Now we are in ECC demo. Okay, and let's assume, unfortunately we have only one server in the system. If you have more than one server but you have logged into this specific server, how do you switch to the next server? You simply select that one, double click on that, then it will switch to the next server. Okay, then you can see here the server name has changed. Here we have only one server, that's the reason we couldn't do that. Okay, you simply go to SM50 and select the server, just double click on the server, then you can see the server name is changed. to the specific server which you have double clicked and where you want to go. There, if you can see the same thing, like if you double click here, you can see the process running. So we have different method. Okay, you, let's say first thing is if you go to SM50, if you go to SM50, you can see all the process running in this specific server. Otherwise, you go to SAP menu, tools, administration, monitor, system monitoring, and process overview. It will come here. Otherwise, you go to SM51. Okay, select the specific server where you want to go. The other two methods will show only the present server where you logged in. If you want to go to a specific server, just double click there, then you can see all the process running. Now you can see here the process running. You can see DIA means dialog work process. We have 1 2 3 4 5 6 7 8 9 10 work process running, 10 dialog work process running, and you have one update work process, that is U. Okay, and we have NQE, and we have 1 2 3 background work process, and we have one spool work process. We have one update to work process. It's an additional work process which will be supporting the update work process. Okay, so if we go back to our presentation, the ABAP message server provides the application server ABAP with the central message services for internal communication. Okay, for example, starting update, when we should start update. Okay, or requesting and removing the logs. Okay, these are all done by the message server. Let's say for example one dialog instance, one specific work process want to release some logs, so it goes to the message server will in turn talk to the NQ, and it will remove the logs. Yeah, these kind of things are done by message services. And message service also provides which are all the instance presently available in a specific landscape. Okay, so if let's say if when we went to SM51, you get all the instances, all the dialog instances and the central instance available in the system because of the message server, because message server collects and keeps all this information. Meaning to say, when you log on to your SAP system using SAP GUI or Java GUI to log in a logon group, that means the collection of all the instances. So the message server performs the load balancing of the available instance. Okay, so let's assume you have more than one dialog instance, and like this 3 4, the message server is only one. When you log in from an SAP system, it will directly go to the message server. The message server will do the load balancing, and it will reroute that specific request, your login, to one specific instance. Okay, that's the way you get the server name where you logged in. However, if you are logging using web browser, then the ICM, the Internet Communication Manager, will do the dispatching of the instances. Okay, let's say if you are logging in, you can also see an arrow mark directly coming to the dispatcher. So let's say right now in the SAP GUI what we have configured, we are directly logging to the system. Okay, we are not using a logon group. In that case, you will directly log into one system. Okay, don't get confused. This is very important. This is very basic of the SAP system. You have central instance and dialog instance. Using web GUI, same like what we configured in our SAP system, SAP GUI, it's a direct login to one instance. Okay, so we gave the IP address, if you remember, 192.168, or let's go to the SAP GUI. So let's see in our SAP GUI. This is the system we logged in before. If you go to edit, you can see this is the IP address of the central instance. So you directly logging to the central instance. We are not using logon group. Okay, like this you can directly log into the central instance. Okay, using SAP GUI. That's the reason you have an arrow mark here. And same like that, if you have an additional dialog instance, you can directly put the IP address of that dialog instance or the host name of the dialog instance, and you can directly log into that specific dialog instance. So if you want to switch from one dialog to another dialog as a basis consultant, you can go to SM50 and change it. So now there is a question comes in your mind: is all the user will allowed to do that? No, we will not allow all the user to go to SM50 because this is basis transactions. Yeah, so we should not allow all the user to do that. If you use load balancing, then we will create a group. Yeah, we will not log into SAP GUI like this to each instances. We will create a group with multiple instances. That time SAP GUI, when you log in from the SAP GUI, you will directly come to the message server. So message servers will decide which dialog instance you should log in that specific group. Okay, we will see that how to create the group later, but this is the architecture, this is the concept behind that. Okay, it's very important to understand. Okay, next have a look at to Java architecture. In application server Java, you have central instance, and it is identified by the fact that it has this SDM, which is used for software development manager, and the NQ services are running in the central service instance. Okay, the Java NQ services and the MS message services, and the dialog instance where you have the server processes. In the Java environment, what we call as a for example, all processes and the data schema all together, it's called as Java cluster. Okay, and the individual Java cluster, this whole individual Java cluster will have the node, okay, which has the dispatcher and the Java server. It's called each node, okay, which has the dispatcher and the server. So we can have a overview of the Java instance by looking at to the system configurations. So how do we see the system configuration of Java? So far what we have seen is the ABAP system configuration. To see the Java system configuration, you can use Internet Explorer. Then you go to Internet Explorer. Let's go to Internet Explorer. Now we open Internet Explorer, then you type in the server name. Our server name, let's give the IP address. So this is the IP address of the server name, and the port is 5040. Okay, this is the default port. So select this one and enter. Now you can see the web application server. This is the web application server of the same IP address. This is web application server of the SAP system. Here you have quite a lot of information. We will come to that later wherever it's applicable for us. Then we have system information. If you click here, then it goes to the link, this /SAP/monitor/system information. Then you need to provide your user ID and password for the Java instance. Say OK. Now if you see here, you can see the entire detail of the system ECC. Yeah, this is the host name, this is the port for the message server, this is the port for the NQ server, and we have the Java software components, what all is installed, Java core and Java. And this is the license information. At the moment there's no license information because this is a demo system. There's a This is the host name, and you have the OS. What is the OS? And this has the Java detail. Yeah, what is the Java port? This is the Java secure port, HTTPS port. Yeah, 51, and the P4 port and telnet. Telnet, you can use this port, and the server 0 information and the SDM information. What is the process ID and the SDM port? So you have all the system, whether it is running, it's not running, all the information is available in this particular screen. Okay, and the system processes are. Then you can find more information here in this links, and you can also download the system configuration, and you can almost have all the information related to the system. You can find it here. Okay, this is to find the system information in Java. So let's go back to our presentation. So in brief, the difference from application server ABAP to Java, the message services of AS Java process, a central message services for an internal communication. The Java message service also provide the information in which instances and nodes of Java services which is available. Each node of Java cluster can be communicated directly with the message services. Okay, in the SAP application server Java, the enqueue services hold the logical locks. Okay, each node of SAP cluster can communicate directly with the enqueue, if in terms of it's a server process or the dispatcher. Okay. Next, let us have a look into ABAP as well as Java architecture. So in ABAP and Java architecture, the application server ABAP plus Java, meaning it works with the same SID, the system ID, yeah, the ECC what we have seen. The system ID is same for ABAP as well as Java. So the, for example, our application server what we have is an ABAP plus Java stack, yeah, together. The principally it's all same, yeah. The principally the ABAP stack and the application server Java stack, it's principally separated, we can say. However, there is some particularity which is running integrated in the ABAP plus Java stacks, yeah. And you need to remember this ABAP plus Java stack is sometimes called as, or mostly called as, add-in installation. The add-in installation means like let's say you are designing an SAP system. You initially you thought you want to have ABAP system, yeah. Then after some time you want to install SAP Java stack in the same system. Then you can add this additional installation as a supplementary in the later stage. So that's the reason it's called an add-in installation, yeah. This is possible. So in case of ABAP and Java together in the same system, we need to understand how this is going to work. Okay, so for example, if you log in from SAP GUI and you try to execute something, it will directly log into your SAP system, that is ABAP system, and you will execute some of your transactions, which is very clear, which we know already, yeah. But let's assume that you are going to execute something from a web browser through an internet. Okay, so all the web browser requests will come to the ICM. So as we know now, from web browser you can also use SAP GUI for SAP GUI for HTML. That means if you enable SAP GUI for HTML in your system, from your web browser you can log into your ABAP stack and execute same like whatever you can do in SAP GUI. The same way you can also execute ABAP request from your web browser. Okay, so how it's going to work? Let's assume you are trying to execute something from your web browser. The ICM will take the request, okay, and it will analyze whether the request is an ABAP request or a Java request. If it is an ABAP request, it will go to ABAP. If it is a Java request, it will go to Java. How do we analyze that one? Let's say it's a ABAP WebDin Pro request or a WebDin Pro request. Yeah. If it is, let's say if it is an ABAP WebDin Pro request, then ICM will dispatch that particular request to the ABAP stack. Okay. If it is a Java page, that means JSP, then the ICM will dispatch the request to Java. Okay, that is the main difference. So ICM plays a very important role here to make the decision to say whether this is an ABAP request or Java request. The main advantage here is you have ABAP and Java in the same system, so the request can be combined together for the same system itself. So what happens is, in the case of ABAP plus Java system, the data is kept separately. Yeah, you can see here, you can database for J2EE and database for ABAP. Okay, so all the ABAP schema data is saved in the, all the ABAP database is saved in the ABAP schema, and the data related to Java schema is stored in the Java database. Now it looks little bit confusing. So do we maintain two different database? Meaning, in general, Java will store the Java schema data. So your transactional data in general is saved in the ABAP database. Yeah. So how it's going to happen? There is something called, you can see here, called JCO. It's called Java connector. It is basically a this works on top of a normal RFC. So it's called Java. This is called JCO, Java connector. So this Java connector is used to communicate between ABAP and Java, okay, in the same system. Even it's a separate system also, this JCO will be the one who will be connecting to the both system. So why do we need to have this connected system? Let's say you have a transactional data which is saved in the ABAP database in your normal ABAP stack. So you want to query the data from your Java system, then you can use the JCO and log into your, using the JCO you can get the data from your ABAP stack, as well as you can also do the updates. Okay, using the JCO you can also access the ABAP stack and you can also retrieve the data. That is a important point here. In general, what I have seen is mainly people keep the database in the ABAP stack, but the temporary database, if you want to query something, you want to keep it in your temporary data, then you can keep in the Java schema database, then it will be quite faster. Yeah, that's a one additional advantage what I see. Otherwise, in general, all the transactional data is generally saved in the ABAP database, provided this is a business data are saved in the ABAP stack. It may be quite easy to manage. But if it is something to do with your internal database within the Java itself, then you can maintain it in the Java. It's up to the application how you are going to design it. So why I am saying this one, you don't need to be confused about that, what data will be saved in ABAP and what data will be saved in Java. It depends on the application which they are going to develop. Based on the functional and your developers, they will decide how it's going to be saved. For us to understand is that you can have database in ABAP as well as in Java. The ABAP database can be queried from Java using JCO connector. Okay, that's the main difference here. With this, we are coming to the end of this session. Thank you very much for listening. I will see you in the next session. Bye bye.